Hello and welcome to this video. Today we're going to be looking at the creation of an LCA model for a plastic broom. So I'll be walking you through all the things you need to do to create this model, from creating flows, processes and product systems, to how to run an impact assessment calculation, and working with projects to compare different scenarios. So the first thing we need to do when doing any LCA study is to define the goal and the scope. So the goal of our study is to assess the environmental impacts of a plastic broom with a specific focus on climate change impact. The scope of our study is from the cradle, that's raw material extraction, all the way to the gate, that's the broom after it's finished production at the factory gate, ready to be shipped off. We're going to be working with the free Swiss database BAFU, and we'll be using the EF 3.1 impact assessment method from the openLCA methods pack. The next thing we need to define is the functional unit. The functional unit describes the function of the object of our study and allows a comparison between different things that might fulfill this function. The functional unit should answer the question how much, how long for, what, and in this case our functional unit is one plastic broom. And the bristles in this case will be made of nylon 6 and the handle will be made of polylactic acid, PLA. So I mentioned that we'll be looking at this product from cradle to gate. So that starts with raw material extraction, in this case maize for the PLA and oil for the nylon. And then there's a transport phase there and we have our granular production. So we end up with our polymer granulates. This then gets transported to the place where the broom is manufactured. And we have our components, individual components, the handle and the bristles that are produced. And then the broom is assembled. So we get that goes from the cradle to the gate. And then it's also important to define what is our foreground model and what's our background model. The foreground model is everything that we model by hand within our database, so all of the processes that we define the inputs and outputs for. And the background model is what we connect to in a database to complete the life cycle of our product. So today we'll be looking at two different case studies. We're going to be comparing two scenarios, a German supply chain and a more broad European supply chain. So production is always going to take place in Germany, but you can see here in the purple scenario, transport distances will be a lot shorter than in the red scenario. And so we want to answer the question, how does the increased transport distance affect the environmental impacts of this broom? So without further ado, let's jump into openLCA and get started with the model. Okay, so once you've opened openLCA, you should have your database here once you've imported that. And if you want to learn how to do that, you can check out our tutorial here. And so what I'm going to do is open the database. Okay, so here we see all of the different elements that are part of the database. We're going to start at flows and then work our way up towards projects. To do this environmental assessment of a plastic broom, the first thing we need to do is create flows. So I'm going to open my flows folder here, and I'm going to add a new category, and I'm going to call it broom case study. And you can see here now it's created a new folder for us to organize all of our flows into. So here I can right click and create a new flow. I can give this flow a name. So here I'm going to say plastic broom. This is the name of the flow. I can give it a description. I'm going to choose not to. And I need to select here the flow type. And in this case, this is referring to a product. And the reference flow property, this is very important. So here I'm going to select number. So it's going to be referring to the number of items. So in this case, one plastic broom. So I'll hit finish, and you can see here that I have now a flow that represents my plastic broom. So the next thing we need to do is create the process that represents the production of this plastic broom. So I'm going to scroll up to my processes tab, and again I can create a new folder, a new category, and call it broom case study. And I can right click on there and hit new process. I can give the process a name. So in this case, I'll call it broom production. And so here I can either create a new flow as the quantitative reference, so the thing that this process produces and refers to, or I can select a flow from these folders here. And so I can just go down and select this flow that I created just a minute ago. I can select that and hit finish. And now we have a process that we can work with. So here, if I navigate down at the bottom to inputs and outputs, this is where I can define all of the things that I need to make this broom. So if you remember, we said that this broom has a handle that's made of PLA, polylactic acid, and it has bristles that are made of nylon. So there's a few ways that we can add our inputs and outputs to this process. You can think of them, this is sort of the ingredients list. So just a few things I want to point your attention to. So you have a column for flow. This is where the name of the flow will be displayed. And then we have the amount and the provider. Those are the three main columns that I want to point your attention to. So let's go ahead and add the first flow. I can head here and click on this green plus, and then it'll bring up a list of all the flows in the database. So I can type nylon, for example, and then I can open this folder and see that it says nylon 6 at plant. That's what we want. I'm going to add the flow. So you can see here now it adds with a default amount of 1 kilogram. The next thing I want to do is add the PLA. So another way of doing this is to double click on this area here with the left mouse. So I can do that and then type in lactide and then plastics, biopolymers, polylactide, hit OK. And then the last thing that we need to add is the transport. The materials are going to be transported by a lorry and the 16 to 32 ton weight class. So I'll do transport, freight, lorry, and then I'll choose this one here and hit OK. So now we've got all of the ingredients, so to speak, to make our plastic broom. Now we need to add the amounts. And what I want to show you is how we can not just work with absolute fixed amounts, but we can work with what's called parameters to make our lives a little bit easier when we're modeling. And so if you go down here at the bottom to parameters, parameters basically let you easily change the input values of the flows that you've selected. So here I can hit plus to create a new input parameter, and it's given a default name of P1, but I want to create a parameter that refers to the mass of nylon. So I'm going to type M underscore for mass and then nylon. And I'm going to give it a value of 0.03, 30 grams, like we said. And you can give it a description. It's always a good idea to write a description because you may notice that parameters themselves, they don't have any units. So it's good for just to make a note of what you've defined it as. So I'm going to say mass of nylon in kilograms. Similarly, I want to create a parameter for the PLA, for the mass of the PLA. So what I just did there was double click and that automatically creates a new parameter. And so then I can type M PLA. And just to note, they're not case sensitive, the parameters, but just for legibility, it's nice to use uppercase. And then I can define the mass here as 0.52 kilograms. And I'm going to give it a description and say mass of PLA in kilograms. I also want to create parameters to represent the distances traveled by these raw materials. So I'm going to double click again and to create a new parameter. And I'm going to say D for distance, nylon. And that distance is 50 kilometers. So I'll give it a value of 50. And I will give it a description and say transport distance nylon in kilometers. Again, so I'll create a new parameter. I can either double click or hit this green plus up here. And then I'll say D for distance, and it'll be this time the distance traveled by the PLA from the point of production of the PLA to the point of production of the broom. So and that distance is going to be 200 kilometers. So I can say transport distance PLA in kilometers. Then it's a good idea to save all, so I can hit File, Save All, just to make sure this is all saved. And then I can go back to my Inputs and Outputs tab, and here I can start adding the amounts. So for nylon, remember we created a parameter that's called m_nylon, so m_nylon, and you can see here our little description pops up as well. So I can just double click on this here, or I can finish typing it out. And for the PLA, again, m_PLA. And then finally, for the transport, I'm going to, because it's the same transport process for both of these, they're both transported in the same way, I can sum up the transport for both of them. You might notice here that the unit is ton kilometers, so this is telling me that I need to multiply the weight of my product by the distance it travels. So in this case, I'm going to change the unit by clicking on this field here and selecting kilogram kilometers from the drop-down. So for my nylon, it'll be the mass of nylon multiplied by the distance it travels. So open bracket, m_nylon multiplied by d_nylon, d_nylon, close brackets. So that's the transport, the amount of transport for the nylon. And then to that, I'm going to add, with a plus, open brackets, m_PLA, the mass of my PLA, multiplied by the distance d PLA, close brackets. So that is all the transport we need. So now you can see here, we've got all of our parameters listed in the amounts column. But if we want to see what numerical value those have, we can just go to the right-hand side here and click Show Values. And this will toggle between the parameter view and a numerical view. So you can see here, it's as we defined it, it's 30 grams of nylon 6, 520 grams of PLA. And for the transport, this is the amount in kilogram kilometers that we've ended up with. We can hit Save again, File, Save All. The next thing we need to do is add providers. And a provider essentially tells the software, where is this flow coming from? What supply chain does this need to be connected to upstream to allow us to make our calculation? So in this case, we only have one provider per flow, so we can just select nylon 6 here. This is where it's coming from. Again, for the PLA, if you click the field, select the drop-down menu, select it. For the transport, the same again. So now we have our providers, the software knows where these things are coming from, and we can move on to the next step, which is creating our product system. To create the product system, go back to General Information at the bottom, and click on the button here, Create Product System. So this pop-up comes up, you can give your product system a name, Broom Production, make sure that Preferred Default Providers is selected, and then just make sure that you click on Unit Process as your preferred process type. When that's all done, you can hit Finish, and the software will create your product system. So here we have our product system. You can see the reference flow, the flow property, the unit, and the target amount. So in this case, it's just one broom. So then we can go to the model graph. This is where you can see a visual representation of the ways that your different processes are connected. So here we have our reference process, which is the broom production. You can see all of our inputs at the top here, the nylon, the PLA, and the transport, and the output, which is our finished broom. And then you can see here that the providers that we selected for each one of these flows is listed here. And we can double click, for example, here on the PLA. And now we see all of the inputs and the outputs of the PLA production. And you can basically keep following these processes back up the supply chain to see what goes into creating the flow that you need. So now we've got our product system. This is the point at which we can calculate our environmental impacts. So if we go back to General Information, we can hit Calculate. So here we need to define an impact assessment method. In this case, we'll be working with the EF 3.1 method. So this comes from the openLCA LCA methods pack. You can just choose it from the drop down here. And we'll leave it as lazy/on-demand calculation, and we can just hit finish. So you can see now the calculation is finished, and we've got a few different ways that our results are being visualized. And the one that I want to focus on today is under the tab contribution tree. The contribution tree basically breaks down the different contributions of processes within your product system to the overall environmental impact across the different impact categories. So in this case, we wanted to look at climate change. So I can click on this drop-down menu here and select climate change. And you can see here that 82% of our impacts come from the PLA production, 16% of the impacts come from nylon, and only 1.37% comes from the transport. And we can take it one step more detailed and see within the production of PLA, where are the hotspots? So in this case, it's the natural gas that's used in the production. Corn is also a major hotspot. That's the feedstock for the creation of PLA. 20% contribution comes from there, and so on and so forth. So this is a really powerful way to be able to drill down into your results and see really where are the impacts coming from. So now we've figured out what the impacts are in our base case scenario. The next thing we're going to do is compare the two different supply chains that we talked about. To do this, we're going to use a project. And a project is a place where you can compare multiple different or versions of the same product system to directly compare environmental impacts. So again, I'm going to right-click on the projects folder and add a new category and call it Broom Case Study. And I can right-click that again and create a new project. I'm going to give it a name and say Broom Comparison. There we go. So this is our new project. And you can see if we scroll down here, we have this tab called Compared Product Systems. And this is basically where we can add product systems to compare. So there's a few ways to do it. I can hit this plus button here to add. And this is the product system we created before. So I can just click on that and select OK. And because we want to compare two of the same product system, I'm going to hit plus again and add the same product system again. Now I'm going to give it a name so it's easy to identify. So I'm going to say this is case 1, and the next one is going to be case 2. So that's all good. We can see that the amount that we're referring to is still 1 broom. And the way that we're going to differentiate these two product systems is by using the parameters that we created. So if I scroll down again, I can, under parameters, I can hit plus, and you're going to see that all of the parameters that we produced or that we defined are available here to select. So we're talking about a difference in distance in this case. So I'm going to click on D nylon for my transport distance for the nylon. Scroll down a bit more. So once I've added the parameter for the transport of the nylon, I'm going to hit plus again and do the same thing for PLA. So the transport distance for the PLA, DPLA that we defined, I'll select that and hit OK. So here we can see in our base scenario, we have transport distances of 50 and 200 kilometers respectively. And we said that in our second scenario, the distance traveled by the nylon would be 600 kilometers. So I'll type 600 here. And for the PLA, it would be 800. So now I can just save. So file, save all. Always good to keep saving as you work. And then if I scroll up again, I need to select my impact assessment method. So I'll click on this drop-down menu, and we want to make sure that we use the same impact assessment method. So again, using EF 3.1 from the openLCA methods pack. So I'll click on that. And then what I'll do is I'll create a report. And a report is basically just a nicely formatted way of looking at your results. So I'll hit report and then go back to my project setup. And then I can scroll up and I can hit calculate. So the software will calculate these two product systems with the parameters that I've defined. So you can see here, these are our results. So if I navigate down to the report, we're interested in the climate change impact. So if I scroll down, We have a really nice table here, and I can select basically my different impact categories. So if I hit climate change, you can see here for case 1, the impact was 1.7 kilograms of CO2 equivalent. And for case 2, with the increased transport, it's only gone up to 1.78 kilograms of CO2 equivalent. But you can see there is a higher environmental impact associated with longer transport distances. But because the hotspot was the production of the PLA and not the transport, you can see it doesn't have an outsized impact on the overall climate change impact. So that's just a brief introduction on how to create flows, processes, product systems to run a calculation, and then how to look at different scenarios within the same product system. So let me know if you have any questions in the comments. You can also visit ask.openLCA to ask any questions you might have. And make sure you check out all of our other case studies and tutorials that we have. We have a lot of great resources on the website, openLCA.org. So good luck with your modeling.